Welcome back, ladies and gentlemen. So today we are going to be studying the properties of rhombuses, rectangles, and squares. Oh my. In this lesson, you will learn about three special types of parallelograms. So you're going to notice rhombuses, rectangles, and squares all have the properties of parallelograms, along with other properties. A rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. You can use the following corollaries to prove that a quadrilateral is a rhombus, rectangle, or square without first proving that a quadrilateral is a parallelogram. So the following corollaries are like shortcuts that we can use. A quadrilateral is a rhombus if and only if it has four congruent sides. So remember, with these if and only if statements, they can work both ways. You can start out by saying if it is a rhombus, then the sides are all congruent. And it also works the opposite way. If we start with a quadrilateral that has four congruent sides, then we can say it is a rhombus. A quadrilateral is a rectangle if and only if it has four right angles. So again, it works both ways. If it's a rectangle, we have four right angles. If there are four right angles in the quadrilateral, then it is a rectangle. And finally, a quadrilateral is a square if and only if it is a rhombus and a rectangle. And what that means is that all of the sides are congruent and all of the angles are right angles. Here's a Venn diagram showing those important relationships among parallelograms, rhombuses, rectangles, and squares. So if we look at the square, you can see that obviously it falls into the category of parallelograms, but also it has four congruent sides and four right angles. So it's classified as a rhombus and a rectangle. So try out this example. For any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. Angle Q is congruent to angle S. So is this always or sometimes true? Try to draw a sketch and be able to explain. So here's a picture to go with that. If you look, by definition, a rhombus is a parallelogram with four congruent sides. By theorem 8.4, opposite angles of a parallelogram are congruent. So angle Q is congruent to angle S. Okay, so remember, a rhombus is a parallelogram, so it has this feature of a parallelogram. Therefore, the statement is always true. For any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So angle Q is congruent to angle R. Well, if we draw this picture, I think we are going to see that there are a couple different possibilities. So in this picture, we're drawing it so that angle Q and angle R are congruent. If they are congruent, then all of a sudden, rhombus QRST has become a square. So the only time they would be congruent is if it was also a square. However, not all rhombuses are also squares. So the statement is sometimes true. Classify the special quadrilateral and explain your reasoning. So how would you classify this according to all those properties that we have seen? Quadrilateral has four congruent sides. One of the angles is not a right angle, so the rhombus is not also a square. So we start off by looking and saying it's got four congruent sides, so it has to be a rhombus. Then this angle is not a right angle, so it cannot be a square. So it is just a quadrilateral that is a rhombus. We've seen some information about diagonals of parallelograms. Now we're going to talk about these special quadrilaterals and parallelograms and their diagonals. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So something important to note is that these diagonals are perpendicular, meet at a right angle. Okay, notice this notation. We're talking about segment AC perpendicular to segment BD. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So again, still talking about a rhombus, the diagonals bisect those opposite angles. So segment AC bisects angle BCD and angle BAD. And segment BD bisects angle ABC and ADC. So we've now seen that the diagonals are perpendicular, they bisect the opposite angles, and now this is about a rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. So we know that they bisect each other because a rectangle is a parallelogram and the diagonals of a parallelogram bisect each other. But now it's saying if it's a rectangle, then those diagonals are also congruent. So take a second to think about all the things we know about rectangles. Sketch rectangle ABCD and list everything you know about it. So you need to draw a figure with the following properties. The figure is a parallelogram. The figure has four right angles. So that's where we're starting. Parallel sides and four right angles. Really, we should have those drawn in, the parallelogram part. Also has these properties. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. And the diagonals are also congruent. Okay, recall that biconditionals such as theorem 811 can be rewritten as two parts. To prove a biconditional, you must prove both parts. The conditional statement. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And the converse. If a parallelogram is a rhombus, then its diagonals are perpendicular. So remember, we have to prove both of those to use a biconditional. So let's do that. The diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. I'm going to go through this pretty quickly. but feel free to go back and re-look at it. Basically, if you look at this, we are going to be using some of the information that we've had before. We're going to talk about the triangles that are inside, broken up by the diagonals. We end up showing that triangle BXC is congruent to DXC by side angle side. Using the corresponding parts of congruent triangles are congruent CPCTC. BC is congruent to C or DC. I'm sorry. So, and then since opposite sides are congruent, we can use transitive properties to say all of these parts are congruent. Therefore, it's a rhombus. So this is where we are starting with the diagonals being perpendicular. We can show that it's a rhombus. Okay, let's take a minute to apply some of this knowledge that we've gained into a real-world problem. You're building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Explain. Okay, so I'm going to flip to the next slide where we just look at A. So you're going to notice in this picture, it's a little bit blurry, but this is 44 inches, this is 44 inches, 33 inches, and 33 inches. So can we say that it's a rectangle? We cannot. The opposite sides are congruent. However, in order to be a rectangle, we need to have 4 congruent right angles. And we do not have that information. They may look like it, but it is not information given to us. So we certainly cannot assume that it is true. You measure the diagonals of the opening. The diagonals are 54.8 inches, 55.3 inches. What can you conclude about the shape of the opening? So again, think about what we know as far as the diagonals. What do we need? So we know that the diagonals of a rectangle are congruent. The diagonals of this quadrilateral are not, so it must not be a rectangle. Okay, I think that's all we have. If you guys have any further questions, please make sure that you ask. Good luck getting started on your homework. Here you go.